Okay, so now we've got the tools to handle an application type problem that comes up. So I've got this diagram on the board, but let me read the problem, the setup, and then follow along with the diagram as I'm reading. So it says it says an airplane is flying at an airspeed of 200 miles per hour headed on a southeast bearing of 140 degrees. Okay? So it's on a southeast bearing, right? At 140 degrees of north. Okay? So it's got a bearing of going along this orange line here. Okay? And it's going at 200 miles per hour. That's the speed. So 200 miles per hour. Okay. A north wind, right? So that means from the north going south. It's a north wind, which means it's going to be pushing this way. So the airplane is going along the orange line, but it's got a north wind pushing down to the south, which means it's going to push it off its path a little bit, okay? Which is represented by the purple line. Okay, now, so a north wind is blowing at 16.2 miles per hour. That's this, right? So it's blowing 16.2 miles per hour due south. Okay? Now this one is going 200 miles per hour, but it's going this way, right? Okay, so think about vectors. Think about vectors. Now, what are the ground speed and actual what is the ground speed and actual bearing of the plane? Okay, so if you're on the ground looking at this plane, how fast would it really be going? Okay, and at what angle? What bearing? Okay, so now, so the ground speed is represented by x in the diagram. Oh, I don't have it on there. Okay. That's that vector, x. And what we need to do is we need to find the angle alpha in order to calculate the adjusted bearing, which is going to be 140 degrees plus alpha, right? So to get the real bearing, we have this alpha, so this angle between these two vectors is alpha. And so we know it's going to be 100 degrees plus whatever alpha is. That's going to be the true bearing, okay? And so those are the two things that we need to find. Now, we need to find x. And so since we have this triangle, right? So if we look at the angle BCO, so B, C, oh wait a minute. Is that the angle we want? I want to make sure I drew my Okay. So now, this here, okay, this here is parallel to this here. Okay, now I know I didn't draw it very well. This should be, because this is going due south. So what we're doing is, this should be going down like this, due south. So let me rewrite this so it looks better. Okay, so this is going to be C, B, and X. Okay, so better. So now, this here, okay, because the wind is going due south, right? So again, this angle here, which is 140 degrees from north, and since this is going south, this line and this line are both vertical lines and they're parallel. And then we've got this line that intersects, right? So guess what? This transversal, this is a transversal, and what do we know about transversals? Alternating exterior angles are congruent and alternating interior angles are congruent, okay? And so that's what we have here, alternating angles, okay? And so that means this angle BCA is equal to angle OAC. Okay? So that's going to be 140 degrees. Okay, so now we can use the law of cosines. To find this one, because we know this one, this is going 200 miles per hour, that's there. This is 16.2 miles per hour, so we know the magnitude of this speed, we know the magnitude of this vector, right? So here's real world, right? Speeds, okay? So now we can use the law of cosines that says x squared is going to equal to what? A squared and B squared, right? So it's going to be 200 squared plus 16.2 squared minus, I'm going to write it down here, minus 2 times 200 times 16.2 times cosine of the angle between them, which is 140 degrees. And so now we can put this in our calculator, okay? So all you have to do is put this in your calculator. Oh, hold on a second. Yeah. So you put this in your calculator and you're going to get, where is it at? 45,226 0.41. And so then x is going to be equal to the square root of 45,226.41, which gives us approximately what? 212.7 miles per hour. Now, before we go on to the next thing, ask ourselves, does that make sense? And the answer is yes. Because if we're having a wind go down, right, we're already going in like a downward direction, right? We're going off here, but it makes sense that we've got a tailwind, right? So if we've got a little bit of a tailwind, of course, we should be going faster than 200 miles per hour. So that makes sense. 212.7 miles per hour. So there's one. Now we're going to use the law of sines to find the angle, right? Alpha. So here's alpha, right? So now we're going to use the law of sines here. So we've got alpha, sine of alpha over what? 16.2, right, is equal to what? Sine of 140 degrees over 212.7. And so now if we calculate this, so I'm going to multiply both sides by 16.2 and I get sine alpha is equal to 16.2 times sine of 140 degrees divided by 212.7. And so that's going to be sine alpha is approximately equal to what? So put that in your calculator and you get 0.04896. Okay? And so of course if we take the inverse sine of both sides, we get alpha is approximately equal to 2.8 degrees. Okay, 2.8 degrees. So here's the moment. Here's the moment of truth. So what are the two answers? Okay, the speed, the ground speed of the airplane is 212.7 miles per hour. The bearing, the true bearing of the airplane is what? 100 and what? It's 142.8 because you have to have 140 plus alpha. So the true bearing of the plane is really 142.8 degrees of north. And that's it. Have a great day.